Hello and welcome to Sean White's Solar and Energy Storage Podcast. The title of this podcast is 2020 NEC Article 705, which is Interconnected Power Production Systems, and we're going to look at that from an energy storage system perspective. There's a lot in Article 705 that people are using in the renewable energy industry. Everything here applies to PV systems, but we're just going to give you energy storage system examples this time because people are so used to PV. Let's mix things up a little bit. Everything we say here is going to apply to anything backfeeding the grid, or will apply to a microgrid too. That's an AC microgrid because DC microgrids are in Article 712. Someday they might combine Article 705 and 712 for microgrids because there's more similarities than differences when you're microgridding stuff. What we're going to talk about here is things like anti-islanding, the MIDs, that's the Microgrid Interconnect Devices, IEEE, the Microgrid System definition, 705.11, supply-side connections, some people call that a line-side tap, and 705.12 load-side connections. Then we're going to get into some really cool stuff, which is brand new in the 2020 NEC, which is 705.13, Power Control Systems, that's PCS. Very exciting. And at the end of Article 705 is 705 Part 2, that's AC Microgrids. There was a lot of rearrangement between the 2017 and the 2020 versions of Article 705, Interconnected Power Production Systems. However, what you end up doing mostly is the same, but they did rearrange it a lot. So before we dive in, if you want, you can go to solar.com to get yourself solar and storage educated. Now, on with the show. Here we are, ladies and gentlemen, Article 705, and that stands for Interconnected Electric Power Production Sources in the National Electrical Code. That's Article 705. Very important to do with energy storage systems, since we're mostly talking about energy storage systems that are connected to the grid. For Article 705, 705.1 scope. So a lot of times in the National Electrical Code, you'll see something that says scope, and it says for 705, this article covers installation of one or more electric power production sources operating in parallel with a primary source of electricity. So that means in parallel. So let's just kind of think about that. What do they mean by parallel? You always hear about people hooking up interactive inverters in parallel with the grid. So if you're filling out an interconnection agreement with a utility, it might call it a parallel connected power source. And so let's even think about that as far as we hear about hooking up batteries in series or solar modules in series. When we hook them up in series, it increases the voltage. But when we hook them up in parallel, it does not increase the voltage. So that might be one simple way of looking at things. Another example of parallel connected things are when you have a bunch of circuit breakers connected to a main service panel or a sub panel. Those circuit breakers are connected in parallel. So those are just some examples of parallel. And the primary power source that we're talking about, primary sources of electricity, typically we're talking about the grid. And so they're calling it, in this informational note, they're calling it utility supply or an on-site electric power source. So usually, almost always, we're talking about hooking our energy storage systems up to the utility. However, we could have our own microgrid. So now, 705.2 definitions. And this time it says the definitions in this section shall apply within this article and throughout the code. So a lot of the different articles that we've looked at, the definitions only applied within this article, but 705 is so special, these definitions apply throughout the code. So what we're going to look at is the Microgrid Interconnect Device, the MID, having an automatic transfer switch, but if we call it a Microgrid Interconnect Device, that's a little bit better. So this means that it does something called anti-islanding. So if the grid is down, it can automatically disconnect from the grid because you're not allowed to feed the grid when the grid is down. So the definition for microgrid interconnect device that applies throughout the code is a device that enables a microgrid system to separate from and reconnect to operate in parallel with a primary power source. informational note. And remember, informational notes are not a part of the code that you have to follow, but it has a lot of good ideas. And it's just talking about all the different standards for microgrid interconnect devices. And there's IEEE standards. And IEEE stands for Institute of Electrical and Electronic Engineers, IEEE. And if you want, you can join the IEEE, and that's the Institute of Electrical and Electronics Engineers, IEEE. Okay, on to the next thing that we're going to talk about is Microgrid System. And another thing too is when you see the symbol, that's called a delta symbol. And in math, you'll see the delta symbol, and that means change. In the National Electrical Code, this Greek letter delta means that something was changed. Other ways to tell that something has changed or could be new is if it's highlighted. And let's read what a microgrid system is. According to this definition in Article 705, is a premises wiring system that has generation, energy storage, and loads, or any combination thereof that includes the ability to disconnect from and parallel with the primary source. One of the things that people get a little bit confused about, and one of the reasons why this is probably going to be changed, is you can have a mountaintop microgrid system. That means that it will never connect to the grid. So that would be its own microgrid system without a grid connection. And so some people would say like, well, if a grid did come there someday, you would figure out how to parallel that to the grid. But the question is, could you have a microgrid system that would never connect to the grid? And most experts would say yes. However, this definition makes it look a little bit like you would have to be able to connect to and disconnect from the grid. So it looks like this definition will be changed someday in the National Electrical Code. Most microgrids will be able to disconnect and connect to the grid, but if you had your own microgrid system because you had a mountaintop that was nowhere near a utility, we could still call that a microgrid system. And now the last definition that we have is a new definition. That's what that N stands for, is new, and it's power source output circuit. It says the conductors between the power production equipment and the service or distribution equipment. So think of this as being the output of your energy storage system inverter. And so that would be perhaps the output between there and a subpanel, which is a type of distribution equipment, or it could be even service equipment. So the power source output circuit, it almost doesn't even have to be explained because it just sounds obvious. It's coming out of your power source, so it's coming out of your interactive inverter. And remember that Article 705 doesn't just cover energy storage systems, it also covers solar inverters. Just think of any kind of inverter that could put electricity back on the grid. And so it's those conductors that are going out to your service or distribution equipment. Distribution equipment is oftentimes going to be a load center, which could also be called a main service panel or a sub panel, or a panel board. And now we're going to go through a few things, and a lot of this stuff just happens over and over again. You have to have the correct type of equipment. Your equipment has to be installed by qualified persons. That's a pretty common theme throughout the National Electrical Code. And what makes you qualified? It's up to the authority having jurisdiction, and perhaps it is taking and completing class. Now we have identification of power sources, and it happens over and over throughout the code. And so if you have different power sources in different locations and say that there was a fire, then if somebody goes to one source, they have to be able to know that there's other sources that they also have to turn off. So if everything's in the same location, that's exceptions, then you don't need to have a sign, which is called a plaque or directory. But if things are in different locations, then you have to have a sign that says, caution, multiple sources of power, and let people know with a plaque or directory where these other sources of power are so somebody can go and turn them all off. Now we're going to get into the main part of Article 705, where most people spend most of their time in Article 705, and that will be 705.11 and 705.12. 705.11 is called supply side source connections, and 705.12 is called load side source connections. So we have supply side and load side. And this is all relative which side of the main service disconnect that you're talking about. So if you are on the supply side, that's like the utility side of the main breaker. That would be called a supply side connection. A lot of people call it a line side tap when you're making a connection there. So just think about this. It's typically going to be between the meter and the main breaker. Sometimes though, however, with maybe a large utility scale system or a feed-in tariff, you might be even connecting on the supply supply side of the meter. Most people aren't connecting on the supply side of the meter, so usually, almost always, a supply side connection will be between your meter and your main breaker. That means it's before any overcurrent protection device. So you're on the utility side of all overcurrent protection, and that would be a supply side source connection. A lot of times people will do a supply side connection when they can't do a load side connection. So a load side connection is a little bit easier most of the time, because with a load side connection, you're just popping in a circuit breaker on a load center. So you can turn off the main breaker and pop in a circuit breaker. But when you do a load side connection, you're allowing extra currents to go after you're protected by overcurrent protection by that main breaker. And how much in the way of extra currents are you going to allow over there? We'll get into that when we get into the load side connections. So when you're doing a supply side connection, you can do a whole lot there. You can put a lot of electricity there over on a supply side connection. And then let's even mention something that's coming up even further on. This is a brand new thing for the 2020 National Electrical Code, and it is called a power control system. So instead of doing a supply side connection or a typical load side connection, you can have a power control system, and then you wouldn't have to follow these rules of 705.11 supply side connections and 705.12 load side connections. Back to 705.11 supply side source connections. It says the sum of the power source continuous current output ratings on a service other than those controlled in accordance with 705.13. That was just that 705.13 that we were talking about, which was power control systems. So the sum of the power source continuous current output ratings on a service other than those in accordance with 705.13 shall not exceed the ampacity of the service conductors. So this just means that if we sum up all of the current ratings of the inverters that are connected on the supply side, that we cannot exceed the ampacity of those wires that are coming to your main breaker. So that means if you have service conductors that can handle 205 amps, then your inverter currents cannot exceed 205 amps. And those service conductors, we could go to Article 100 definitions and look at these service conductors. Those are just the wires that are coming to your main breaker. And then there's some other things. There's a certain size. If you are going to do a supply side connection, that you can't go smaller than a 6-gauge copper wire. And then there's certain lengths where you can't go too far without having overcurrent protection. So you're not going to go a long distance before you're going to have your overcurrent protection. You need to use the proper listed connectors. And so connector is how you connect different wires together. And there's certain requirements for ground fault protection, which is just going to always be built into your inverter pretty much every time you're dealing with that. And that brings us to the end of 705.11. And then we are on to the very interesting and sometimes hard to explain 705.12 load side source connections. Some of you may have heard of the 120% rule. That's one of these ways of doing these things with a load side source connection. 705.12 load side source connections are connections that we make on the load side. That means the customer side of the main overcurrent protection device. So if you're thinking about your house, it would be the first circuit breaker between the utility and you. So think of that. After the meter, there is some way to turn off the system, and an overcurrent protection device that would be considered your main service disconnect. And if you are on the utility side of the main service disconnect, that would be something that we just talked about. That's 705.11. That is a supply side connection. And now we have 705.12, the load side connection. We're going to talk about load side connections. And it's a lot nicer to be able to do a load side connection because you turn off the breaker and then you're not going to get electrocuted while you're making a connection. You're never supposed to work on anything hot anyway, unless somebody's life depends on it, like you were working on a hospital. So to turn off the electricity on the supply side, if you're working on somebody's house, you're supposed to pull out the meter, and you would probably need utility permission to pull the meter out. So that's how to turn some things off. But when you're talking about commercial buildings, you can't pull the meter and turn the system off because the power does not run through the meter on these bigger systems. They use what's called CT, that's current transducer metering on these big commercial utility buildings. And a CT works sort of like a transformer. It's just a little hoop that goes around a wire. We do that for monitoring things. We can tell how much current is going down a wire. So back to load side connections. There's different ways to add electricity with interactive inverters, and that is typically going to be an energy storage system or a solar system. And in the future, it could be your car, which really is an energy storage system. 705.12a, dedicated overcurrent and disconnect. And pretty much what this means is that you cannot have one circuit breaker for an inverter and a load, because that's not dedicated. And so that's why you can't just get an interactive inverter and plug it into the wall. It might be neat, it might be easy, but if you could just plug an interactive inverter into the wall, you might have inverters there, you might have loads there, and you could end up with too many things that could cause a fire hazard. I mean, just think about it. If you bought a new interactive inverter every month and a new power strip every few months, you could have a whole lot of interactive inverters and a bunch of loads on the same circuit. Something could go wrong. So you can't just plug an interactive inverter into your wall legally. Okay, and then 705.12b, it's just going to tell us, in most of our calculations, we're going to use the inverter current multiplied by 125%. That's pretty typical for how you do calculations, is the inverter current times 125%, and that's going to be for B1 through B3. B1 is feeders, B2 is taps, and B3 is bus bars. In fact, there's only one way where you're not going to use 125% of inverter current, and it's going to tell us on 705.12b33. I call that the sum rule, as in SUM. Now taps, and taps are covered in 705.12b2. And it just tells us to go to 240.21 tap rules. And there's the 10-foot tap rule and the 25-foot tap rule. So if you're already an electrician and you might know about these tap rules, or an electrical engineer, you just add 125% of the inverter current to the rating of the feeder breaker. These tap rules aren't used that often in the solar industry, and they're kind of advanced and probably would take about an hour to explain. So if you want to know more about the tap rules, I would suggest reading my book, PV and the NEC, because even though it's called PV and the NEC, it covers energy storage. Now the bus bar rules, that's 705.12b3, and there's b31 through b36. And what a bus bar is, it's a common piece of metal where you can connect a bunch of things together in parallel. A good example of a bus bar would be your main service panel. You're hooking a bunch of breakers up to that in parallel, or a sub panel. We can also call those load centers. Now we have the sum rule, where you sum everything up. This was put into the NEC in the 2014 National Electrical Code, but the name of it has changed. However, it's the same thing, 705.12b33. So what we do here is have this sign that says, this equipment fed by multiple sources. Total rating of all overcurrent devices, excluding the main supply overcurrent device, shall not exceed the ampacity of the bus bar. So if we had a 100 amp bus bar, we can't have more than 100 amps of breakers on it. And we ignore if they're solar breakers or load breakers. We just can't have more than 100 amps of breakers on it. And we ignore the main breaker. We ignore the main supply overcurrent device. The reason that they came up with this was for combining interactive inverters. So if you wanted to combine a bunch of interactive inverters, you can use this rule. That's 705.12b33, which I like to call the sum rule. Sum it up. You just sum up all breakers. You read the label and it tells you pretty much what to do. It's really easy. Now, something that has changed a little bit over the years, sometimes you will have a bus bar that's fed from the middle. We call that a center-fed bus bar, the main breaker's in the middle. It used to be that we could not do the 120% rule with center-fed bus bars, but now we can. So if I had a 200 amp bus bar and a 200 amp main breaker, I go 200 times 1.2 is 240. And so I have 40 amp allowance, and I could put a 20 amp breaker on one end and a 20 amp breaker on the other end. Or I could put two 20 amp breakers on one end, or I could put two 20 amp breakers on the other end. I cannot put 40 amps on one end, 40 amps on the other end, because that would be 140%. And it's not called the 140% rule. It is called 705.12b34. The center-fed bus bars are more common in the western part of the United States. And now we have 705.12b35 for multi-ampacity bus bars, and this is a way underused way of doing things. So if you have an engineer that's going to be working on your project like you do with almost all commercial projects, under engineering supervision, that engineer can let you do things that are outside of the scope of the National Electrical Code. So they could do things under engineering supervision and perhaps put 40 amps on one end and then 40 amps on the other end. But that would have to be under the license of a professional engineer, also known as a PE. That's somebody that took a really hard test. Engineering supervision. Then special bus bars with feed-through conductors. A feed-through conductor is sort of like at the bottom of a bus bar, say in your main service panel. You have a couple of lugs there, and it's like you're extending the bus bar. Not a very common thing to deal with, but it's just like it sounds. You're pretty much looking at this as if you're extending the bus bar. And so when you're making a connection with feed-through conductors, you're following the bus bar rules B1 through 3. The 100% rule, the 120% rule, and the sum rule. So we've pretty much made it through 705.12b3 bus bars, and that's pretty much the meat and bones of Article 705, interconnected power production sources. It says we should mark things. If there's multiple sources, we want to put a marking there, and then they need to be suitable for backfeed. And an old thing, it says circuit breakers not marked line and load shall be considered suitable for backfeed. So line means going to the utility, load means going to the load, but this is new. Circuit breakers marked line and load shall be considered suitable for backfeed or reverse current if specifically rated. So you can even have something that is marked line and load and still backfeed it. That is new, as long as it's rated to be able to do that. And then 705.12e, this is for fastening. So if you look at your main breaker, you can't just pop it right off like you can a load breaker. With interactive inverters that do anti-islanding that turn off immediately when there's no grid, you don't have to fasten those. You can still use plug-in type of circuit breakers. So the circuit breakers that you could just pull off, because if the breaker falls off with the interactive inverter, it will immediately de-energized. But with a standalone inverter circuit, you have to fasten it. Once in a while, you'll see an inspector that wants you to fasten it for an interactive inverter, and you just bring them over 705.12e and you say, hey, look, I don't have to fasten it because this inverter will anti-island. Okay, now for the big drum roll. It is very short. It is 705.13, and it is very important new thing in the National Electrical Code. So I'm just going to read this. 705.13 Power Control Systems. Power control system, PCS, shall be listed and evaluated to control the output of one or more power production sources, energy storage systems, and other equipment. The power control system shall limit current and loading on the bus bars and conductors supplied by the power control system. For the circuits connected to a power control system, the power control system shall limit the current to the ampacity of these conductors or the ratings of the bus bars to which it is connected in accordance with 705.13a through E. And then there's A through E, the different ways that we can work with power control systems. And so pretty much what we're saying is we can use a brain instead of using other ways that we've always done things. So this is brand new in the 2020 National Electrical Code. It's not something that's widely used yet, but as we start adding more and more things that backfeed the grid, we're going to have a lot more options for doing things when we have a brain, a power control system. And 705.13 Power Control Systems, which was just something that's super neat in the National Electrical Code for those of you NEC nerds out there, and talking about the loss of the primary power source. So if the grid goes down, you cannot feed the grid. Just know that. You cannot feed a grid when the grid goes down because you might hurt an electrical worker up there that's trying to fix things, and then you send some electricity back to the grid, and you're never going to have enough power to feed the whole grid anyway coming from your building. So you need to go into island mode. And island mode means that you disconnect from the grid. You can still work off grid, but you have to be in island mode. You can't be feeding the grid when the grid is down. And then we don't want to unbalance the voltages on our grid too much. However, it's possible to make the grid more balanced. If you have too many loads on one line, then your voltage drops, and you can compensate for that by putting the opposite of a load, the anti-load. That's also known as an interactive inverter feeding the grid, and that can boost up the voltage, unlike a load which brings the voltage down. So they cancel each other out. It's kind of neat. And now the end of Article 705, and this has to do with AC microgrids, and they might bring 705.12 here for DC microgrids. We have Part 2 of Article 705 for the 2020 National Electrical Code. It has been rearranged since earlier versions of the code and covers the AC microgrid. There's not too much to it. Microgrid systems shall be permitted. You can disconnect from the grid and work in island mode. Very much like Article 712 DC microgrids, they're so much alike that they may be combined together in the future. So I hope you enjoyed our little talk about the National Electrical Code, which is published by the National Fire Protection Association. And once again, don't get frustrated learning about the National Electrical Code. It takes people a lifetime to really learn this, and they still don't really learn it. People that have spent a lifetime working on the code, people that write the code, they don't understand it. They approach understanding. So I hope you have approached understanding more so. Thank you very much.
Thanks for listening to Sean White's Solar and Energy Storage Podcast. To find out more about everything under the sun, or you could say under the moon for storage, go to solarsean.com.